Meet Maya. It's Friday night, and she's at her best friend's house for game night. They pull out a board game with a big six-sided die. Her friend says, "I bet you can't roll a 4." And Maya thinks, wait, what are actually the chances of that? That question right there? That's probability. And by the end of this video, Maya and you will know exactly how to calculate it. Let's go. So what exactly is probability? Probability is a way of measuring how likely something is to happen. Think of it like a sliding scale. On one end, you have 0. That means something is impossible, like rolling a 7 on a regular six-sided die. Can't happen. On the other end, you have 1. That means something is certain, like rolling a number between 1 and 6. That's going to happen every single time. Most events fall somewhere in between. We usually write probability as a fraction. Pretty cool, right?
Here's the magic formula, and it's simpler than you think. Probability equals the number of favorable outcomes divided by the total number of possible outcomes. Favorable outcomes are the results you're looking for, the ones you want. Total outcomes are every single thing that could possibly happen. So if Maya wants to roll a 4, there's 1 favorable outcome, rolling a 4, and 6 total outcomes, since the die has 6 sides. That gives us 1/6. That's her probability. Let's make sure we really understand this formula before we dive into examples.
Before we calculate any probability, we need to know our sample space. That's just a fancy term for the complete list of all possible outcomes. For a standard six-sided die, the sample space is 1, 2, 3, 4, 5, and 6. That's 6 total outcomes. For a coin flip, the sample space is heads or tails, just 2 outcomes. Maya learned this trick. Always write out your sample space first. Once you know all the possibilities, the formula becomes super easy to use. This is literally step 1, every single time. Now, let's talk about the different types of events. A certain event has a probability of 1. It always happens, like rolling a number less than 10 on a regular die. Guaranteed. An impossible event has a probability of 0. It never happens, like rolling an 8 on a six-sided die. No way. Events that are likely have probabilities closer to 1, and unlikely events have probabilities closer to 0. Maya realized that even without calculating, you can make smart guesses just by thinking about whether something is likely or unlikely. That intuition plus the formula? Unstoppable combo. All right, let's solve Maya's original question. What is the probability of rolling a 4 on a six-sided die? Step 1. Identify favorable outcomes. There's exactly 1 4 on the die, so favorable outcomes equals 1. Step 2. Count total outcomes. The die has 6 faces, so total outcomes equal 6. Step 3. Write the fraction, 1/6. That fraction is already in simplest form, since 1 and 6 share no common factors. So the probability of rolling a 4 is 1 out of 6. Maya's got her answer, and now you do too. Now let's level up. What is the probability of rolling an even number on a six-sided die? Step 1. Find the favorable outcomes. The even numbers on a die are 2, 4, and 6. That's 3 favorable outcomes. Step 2. Total outcomes is still 6, since the die has 6 faces. Step 3. Write the fraction, 3/6. But wait, can we simplify? 3 and 6 are both divisible by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So 3/6 simplifies to 1/2. The probability of rolling an even number is 1/2. Makes sense. Exactly half the numbers are even. Let's try a coin flip. Maya flips a fair coin. What is the probability of getting heads? Step 1. List the sample space. A coin has 2 sides, heads and tails. Total outcomes equals 2. Step 2. How many favorable outcomes? We want heads, and there's exactly 1 heads on a coin. Favorable outcomes equals 1. Step 3. Write the fraction, 1/2. That's already fully simplified. So the probability of flipping heads is 1/2, which is also 50%. There's an equal chance of heads or tails. Makes perfect sense for a fair coin. Maya nails it again. Now here's a fun one. Maya finds a spinner at the game night with 8 equal sections. The sections are numbered 1 through 8. What is the probability of landing on a number greater than 5? Step 1. Find favorable outcomes. Numbers greater than 5 are 6, 7, and 8. That's 3 favorable outcomes. Step 2. Total outcomes is 8 sections. Step 3. Write the fraction, 3 over 8. Can we simplify? 3 and 8 share no common factors, so 3 over 8 is already fully simplified. The probability of landing on a number greater than 5 is 3 out of 8. Great job, Maya! There's a bag at game night with 5 red marbles, 3 blue marbles, and 2 green marbles. That's 10 marbles total. What is the probability of picking a blue marble at random? Step 1. Favorable outcomes. There are 3 blue marbles, so favorable equals 3. Step 2. Total outcomes. 5 plus 3 plus 2 equals 10 marbles in total. Step 3. Write the fraction, 3 over 10. Can we simplify? 3 and 10 share no common factors, so 3 over 10 stays as is. The probability of picking a blue marble is 3 out of 10. Before we wrap up, here are Maya's top 4 probability tips that she picked up tonight, and they'll save you on every single problem. Number 1. Always write your sample space first. List every possible outcome before you do anything else. Number 2. Always simplify your fraction. An unsimplified answer might be marked wrong on a test. Number 3. Double-check that your answer is between 0 and 1. If you get something bigger than 1, you made an error somewhere. And number 4. Reread the question. Students lose points just by solving the wrong thing. Slow down and read carefully. You've got this. Remember when Maya was staring at that die, totally stumped? Now look at her. She's calculating probabilities in seconds and winning at game night. And you've done the same thing in this video. The probability formula is your new superpower. Favorable outcomes over total outcomes. List your sample space, count what you want, divide by the total, and simplify. That's it. Whether it's a die, a coin, a spinner, or a bag of marbles, same formula every time. You are officially a probability pro. Now go show the world.